In Chapter 4, Unit 4, we're going to be looking at how we can use linear inequalities to solve real-world problems. And this is a short unit, but it is a really cool unit in my opinion. So, we're going to be graphing linear inequalities in two variables. We're going to review that. And then we're going to get into its applications. Pretty simple. So let's review graphing inequalities. So I'm going to kind of adjust my camera here today. To graph this, one of the easier ways is to actually rewrite it in a y, with y on one side, kind of like y equals mx plus b. So we're going to kind of solve for y. So we're going to need to subtract the 4x. So here, let me rewrite it. If I subtract the 4x from each side, I get negative 2y is less than or equal to negative 4x plus 6. I need to divide by the negative 2, but that's going to give me y is greater than, because remember the symbol flips if you divide by a negative, 2x minus 3. Now we know how to graph the line y equals 2x minus 3. It would have a y-intercept at negative 3 and a slope of 2. Now, if it had just been greater than or a less than, I would actually leave the line dotted. But since this one is solid, I'm going to actually solid it in. Since it's underlined, we're going to solid it in. So like the open closed circle thing. If it's open, it's going to be dashed line or dotted line. If it's underlined like a closed circle, you're going to have a solid line. Now we just need to figure out where to shade. So a lot of times when we're starting out, we kind of figure that out by plugging in a point. Like 0, 0 would be a great point to plug in. And if it makes the inequality true, we'll shade the side with the trues. And we don't shade the false side. So if I plug in 0, 0, I get 0 is greater than or equal to 0 minus 3, which is negative 3, which 0 is. So this is the section we want to shade. Another way you can tell is if y is greater, then we're going to be shading above on the y-axis. So we'll be going this way, which is up. If it had been less than, we'd be going down. Now, in a system of inequalities, we have more than one line being graphed on the same grid. So I'm going to kind of do this in colors. Let's take the first one in green. Okay, so the first one would be 3x minus 2y is greater than or equal to 4, and we'll solve for y. Again, remember if I divide by that negative, it's going to flip this symbol. And let's go ahead and graph that line. While we're plotting the points, let's think about, is this going to be a solid or a dashed line? Up 3 over 2, up 3 over 2, up 3 over 2, and back. Since it is or equal to, then we are going to have a solid line here. Now, which way are we going to shade? This one is less than. So it's actually going to be shading down from there. So right now I'm just going to kind of do a light, 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 light. Now we're going to graph the other one on the same grid. Solve for y. So that would make this negative x and a plus 3. So 3 down 1 over 1, down 1 over 1. And this one stays dotted because it is not underlined. And it's greater than, so we're going to be shading up. Now, for a system, we want the area that is shaded for both graphs. So that's actually going to be this section right here. That's where everything meets. That meets all the conditions. A good point to recognize also is where these two are crossing. That's going to be very, very important. That point where they're touching. And that one's easy to see graphically. It's 2, 1. We'll talk about how to find that. That's the intersection of those two lines. That's going to be really important when we get to the linear programming part. But right now we're just practicing the graphing part. So this one now has 4 in it. Okay, so let's take the first one and solve for y. And I should have used other colors. I will for the next one. Okay, the next one is 2x plus y is less than or equal to 14. Y is less than or equal to negative 2x plus 14. Which is actually going to be pretty far off my graph, but that's okay. We'll see what we can do here. It might actually be easier to figure out where my x-intercept is on that one. Sometimes it is actually easier to look at your x and your y-intercepts. So let's go ahead and graph that first one. It's got a 5, and it's down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, and backwards. And that one is going to be a solid line. And less than would mean we're going to be going under that line. Okay? All right. The next one, 14 so far off. Let me go back up here. So the y-intercept's at 14. My x-intercept's actually going to be at 7. So that's a good thing to know. And it's down 2 over 1, down 2 over 1. And then I could go backwards. And I already see where the two are meeting. That's good. And this one's also going to be solid. And they're meeting at this point 6, 2. And we're shading underneath that one. Okay, so we kind of see where they're crisscrossing already. The next condition says we want all the x's that are greater than 0. So that means we don't want any negatives over here. So greater than or equal to 0 would mean we're starting at this x-axis and we're going to the right. And I just realized I have a typo. Oh gosh, all these typos. This should be y is greater than or equal to 0. And so we're also above this axis. So we're really talking about this shaded region right here. And so notice that there's a lot of corners on that shaded region. We have the origin. We have this point, which is 0, 5. We have this point over here, which was 7, 0, and we have the 6, 2. All of those points are going to be very important when we're doing some solving. Those are called the corners of the region. So the next thing we're going to do is do a real life application. So CDF Appliances has assembly plants in Atlanta and Fort Worth, where the company produces a variety of kitchen appliances, including a 12-cup coffee maker and a cappuccino machine. At the Atlanta plant, 160 of the coffee makers and 200 of the cappuccino machines can be assembled each hour. At the Fort Worth plant, it's 800 of the coffee makers and 200 of the cappuccino machines. CDF Appliances expects orders for at least 64,000 coffee makers and 40,000 cappuccino machines. At each plant, the number of assembly hours assembled for these two appliances is constrained by each plant's capacity. Okay, so sometimes it's helpful to kind of make a little table maybe. So we'll make the table. So we have these coffee makers and the cappuccino machines. I cannot spell cappuccino. Okay. And they're being made in Atlanta and Fort Worth. And it says in the Atlanta plant, we're doing 160 per hour and 200 per hour of these. And Fort Worth says 800 per hour and 200 per hour. And we need, so this is the needed part, needed at least 64,000. And here is at least 40,000. So let's think about at least. At least means we could have that or more. Now the hours, let's let X be the number of hours at the Atlanta plant. And let's let Y be the number of hours in Fort Worth. So if it's 160 per hour, then that would be, and I'm sorry my previous page kind of bled through, 160x. And then this would be 800y, needs to be at least greater than or equal to 64,000. For the cappuccino machines, we have 200 in Atlanta plus 200 in Fort Worth, and we want at least 40,000. Now what else has to be true about these hours? We cannot have negative hours. So we could kind of simplify these a little bit if we wanted to. I'm going to kind of talk about this a little different here. A quick way to graph these is actually with the intercepts. Alright, so I'm going to find the X and the Y intercepts for the first one. So let's kind of make a little chart here. X-intercept and Y-intercept. Remember, that's a pretty fast way of doing it, because the X-intercept, we're going to let Y be 0. So I'm going to do 64,000 divided by 160. And my X-intercept's at 400 for this one. And the Y-intercept divided by 800 is going to be at 80. Now let's look at the cappuccino machine. So for the X-intercept, we'll take 40,000 divided by 200. And then Oh, it's going to be the same. It's going to be 200 here as well. So since our intercepts are that big, we're probably going to be plotting it by hundreds, huh? 100, 200, 300, and 400. And then 100, 200, 300. Notice I'm only using the first section because everything's got to be positive. So the first line has an x-intercept at 400 and a y-intercept at 80. The next one is an x-intercept at 200 and a y-intercept at 200. So it's going to look like this. Now this one says we want greater than or equal to. So that's going to be above both lines. So our key points are going to be this corner here, and this corner right here, which we could find by solving that system of equations. But we didn't have to, it just said to graph it for this one.